We're getting out to the cold outer fringes of our solar system, but we really have a long way to go as far as distance goes. But Uranus is pretty far out there. The semi-major axis of Uranus is about twice that of Saturn, which itself was twice that of Jupiter. Semi-major axis of Uranus is 19.2 astronomical units. So we are a long way out. We're now 20 times further out than the Earth-Sun distance. So we're not 93 million miles out. We're more like 2 billion miles out now. Way far away from the sun. 19.2 astronomical units. Out there, the orbital period is really slow. It's about 84, or really long, about 84 Earth years. It takes 84 Earth years for Uranus to make a complete orbit. Basically a human lifetime for Uranus to complete one swing around the sun. Rotational period, here's another weird number, minus 0.72 Earth days. This is about 17 hours, but notice the minus sign. Looks like Venus's minus sign, and we'll say some words about that minus sign in just a minute. The mass of Uranus is about 15. Remember, Saturn was about 95. So Uranus is distinctly less. It's still way, way more massive than the Earth, but we're now talking about a different order of magnitude here. As you can see in the next number, which is the radius, which puts us at 4.0 Earth radii. So you can put about 4 of Earth's moons across the face of the Earth and about 4 Earths across Uranus. So the moon is to Earth as Earth is to Uranus. Okay, about a factor of 4 in both cases. Number of moons, we're up at 27, plenty of moons. Remember, the outer planets all have loads of moons. Inner planets have very few. The density, a little bit more than Jupiter, but nothing like so low as Saturn. Okay, this is more dense than water. Uranus, unlike Saturn, would sink in a big enough bathtub. Here we go. The obliquity of, that is the axial tilt of Uranus, 98 degrees. Check that out. Right, the Earth is at 23 degrees, 23 and a half degrees, which is, in Saturn's a little more than that, but Uranus is 90 plus 8 more. So it really orbits on its side. We'll get back to that. Magnetic field of Uranus is about twice that of the Earth. Eccentricity 0.046, so sizable, but nothing to write home to mom and dad about. Surface temperature 72 kelvins, which is, 76 kelvins. 76 kelvins. So nitrogen would actually be a liquid at this temperature. 76 kelvins, which is the same as about negative 323 degrees Fahrenheit. It just keeps getting colder and colder and colder. Now, a few general remarks about Uranus before I talk about their seasons. Its seasons. The first thing I want to mention is its composition. It's 84% hydrogen, about, let's see, 14% helium, and about 2% CH4, which is methane. Notice this is a dramatic increase from Saturn. Saturn was about 0.2% methane. So now we have more methane. The color of Uranus is kind of blob, but it tends a little bit towards the super faint blue. Okay. It's not really remarkable to look at. It's sort of what my mom would call sort of a seafoam color. It's just faintly greenish bluish. Okay, and that color is due to the methane. Saturn had very little in it, so Saturn was sort of a neutral color, kind of just an eggshell you know, color. But Uranus has a little more methane in it, so it looks slightly green-blue. Okay, kind of a seafoam sort of Martha Stewart green. That's what we call it in our household, the Martha Stewart green-blue color. One more thing I want to say about Uranus before I get into the seasons is this. Historically, there have been 5 planets visible with the naked eye, right? Mercury, Venus, Mars, Jupiter, Saturn. Uranus was thought to be out of that club, but it's not. You can actually see Uranus with your unaided eye if you know exactly where to look and you have perfect conditions and really good eyesight. You can see it. It's super faint. For a couple hundred years, it was classified as a star. It moved so slow, 84 years to go around once, and it's so faint that people didn't realize it was a planet. It does a whole retrograde thing just like all the other planets do, but nobody really noticed that it was a planet before. It was classified in several different catalogs as a star. Because you go out and look at it tonight, go out and look at it next year, it's going to be in about the same place, right? Certainly within a week or two, you're not going to notice its movement. So it was classified as a star. You can see it with the unaided eye. I have actually done it, but it required a finder's chart to show where Uranus was among the background stars, and really good conditions, and you know, a good 10 minutes of work, a little bit of patience to find it. But I have seen it. So it is actually visible with the unaided eye. It's kind of cool. Now here's what the seasons look like on Uranus. Here's the sun. There's the sun. Uranus orbits on its side. And by the way, it has rings, right? And I'm not going to draw them also, but they are also tilted along with it. So I'm going to draw a few pictures here. We're going to look at this sort of as a 3/4 view. So the rotation is like this. It rotates around its axis like that, like that, like that. So it rotates on its side, and also its moons orbit this way. I'm not going to draw them, it would be too much. But this is basically just a picture of a Uranian year. Okay, let's say this whole thing starts off in 1986, which is the year that I graduated from high school. If you want to know how old I am, 1986. 21 years later we'll be at 2007. 21 years after that we'll be in 2028. Just a few years from now, 8 years from now, and then 2049 down here. Okay. So right now we are approaching winter in the northern hemisphere. Okay. This is summer, northern summer. This is northern winter. And so this is what we learn from these two numbers here and here. If this number were less than 90 degrees down here, the obliquity, this would be a positive number. The negative number indicates that it is actually the North Pole is under the ecliptic, is on the south side. So its North Pole is sort of pointing down, whereas most planets' North Poles point above in the picture. So these are the weird seasons, right? And what I want to do is talk about what you would see. Suppose you were standing at the North Pole, right here. What would you see over time? Now this rotates once about every 17 hours. So if we started off here in 1986 and we were at the North Pole, we would see the sun directly over our heads, right? Because we're standing right here, right? This is us, like this. There's your legs. Right over your head is the sun. What you would see is really crazy, and this only happens on Uranus. I'm a little bit, need to get up on a stool so you can see my face better. I've been blocked by my picture here. But what you would see in the 21 years between 1986 and 2007 is you would see the sun continually. It would never set. It It would start overhead, and it would start to, for a while you wouldn't notice anything. But then as you started to move over this way, you would see the sun start to make a spiral, a counterclockwise spiral. Okay. And it would get larger and larger. So it starts at your zenith over your head, and then it would start to make a little spiral around that zenith point. And as it would get lower and lower and lower and lower and lower, and right before you hit 2007, in the year 2006, what the sun would be doing is this orb going around the horizon all the time. And then finally, that spiral would drop below the horizon, and in 2007, the sun would be blocked by Uranus, and you would not see it for another 42 years. So for the next 42 years, between 2027 and 2049, you won't see the sun at all. 42 years of not seeing the sun. What it would be doing is it would continue that spiral, but it would continue spiraling down to the point below your feet. And when you're here, 2028, it would be at your nadir, which is the point directly opposite the zenith, the low point. It would be directly under your feet. The sun would be, because now you're right here, and the sun, Uranus has blocked the sun from you. The sun is now way under your feet. So for 21 years, it spirals from overhead to the horizon during that period. From 2007 to 2028, it continues to spiral downward. In 2028, it reaches the point directly beneath your feet. For the next 21 years, it starts to spiral back up. You still don't see it. Eventually, 42 years after it disappeared, it's going to arrive, it's going to show up again in 2049 on your horizon. For the next 21 years, it's going to spiral upwards. So what you would see is 42 years of the sun spiraling up, spiraling down, and then 42 years of no sun at all. So the seasons on Uranus are crazy, okay? Because you get sunlight on the northern hemisphere for 42 solid years, and then you get darkness for 42 solid years. Then you get sunlight for 42 solid years, and so forth and so on. And we could talk about the way it would look from the equator or from other latitudes, but we're not going to do that. The point is that the seasons on Uranus are unlike any other system and any other body in the solar system. Okay, so this would be summer, winter. This would be our spring here. In the spring, I'm sorry, that would be fall. In Uranian fall, the sun would disappear below the horizon, be gone through the winter, and then rise in the spring, and then spiral upwards, and the first day of summer would be right overhead. And then between the summer and the fall, it would spiral back down again. Just spiral up, spiral down, spiral up, spiral down. Pretty weird, but 100% true. Not making it up. Next up, Neptune, the blue one.